All right, let's take a look at today's lesson. So what we're going to be doing today is we're going to be graphing rational functions. We've done some preparation for that. The last lesson that we did, if you will recall, we looked in detail at trying to find or finding vertical asymptotes. We learned how to do that where we set the denominator equal to 0. So that was from the last lesson. We learned about horizontal and slant asymptotes. And I'm just going to kind of slide up here. Let's look at the notes real quick. The horizontal and slant asymptotes, if you recall, for horizontal, we're looking at the degree of the numerator. If the degree of the numerator is smaller than the degree of the denominator, then our horizontal asymptote would be y equals 0. So that's something that we learned last time. If the degree of the numerator is the same as the degree of the denominator, then we divide the leading coefficients, and that's our horizontal asymptote. And then if the degree of the numerator is greater than one more, then we have a slant asymptote. So this is the information, and we practiced that last time. We practiced on how to find all of those asymptotes. So we're going to be using that information today. We also learned last time about points of discontinuity or holes in the graph. If you recall, I'm just going to, a reminder, if you recall, if we had, say, don't you love it when the computer, there we go. So for example, let's say we had x plus 3, we factored our rational, and we got this when we factored. And then we can see that this would reduce, we would cancel those out, that would leave a hole. And if you remember when we were talking, the hole would be at the x value that would make what we took out 0. So the hole would be at x equals 2. And to find the y value of the hole, we would take that x value and plug it in the leftover part that we haven't canceled out. We would say 2 plus 3 over 2 minus 3, and that would give us a y value of, what, -5. So our hole would be at 2, -5. So that's just a reminder on what we would do, how we would find the holes. Now, one note, there's a couple of other things we need to talk about before we do our examples. One is we always have to remember to factor first. The reason we have to factor first is to see if we've got anything that cancels out, to see if we have a hole. If we don't factor first, then we would miss that concept. We would miss that we'd have a hole and we wouldn't have canceled it out. So really important that you factor first. Another thing that I need to mention is that as horizontal and slant asymptotes go, these two, you will only have one or the other. You will only have one or the other. You will never have both of those things in one equation. Only one or the other, either horizontal or slant, never both. That's another little clue that I need to tell you. And the last thing I want to talk about is the horizontal asymptotes. So last year, our rational functions, behaved normally. This year, the rational functions, sometimes they behave badly. And let me explain what I mean by that. Sometimes they cross the horizontal asymptote. I know that is like, what? You can't cross a horizontal asymptote? Oh, in fact, you can. So let me talk about what that would look like. And I'm going to talk about how we discover if that's the case. That's what with our functions that we're graphing this year, they're more complex. So it is certainly possible that they may cross. So let me give you an example. Let's say we've got a horizontal asymptote here and we've got a vertical asymptote here. Let's just say we've got that going on. We know two asymptotes is two pieces of the graph. So I've got one piece here And my other piece actually looks like this. It comes up and it breaks through. This is a typical thing that it will do. It breaks through and it slides along the top of the asymptote. That's one scenario where it could break through. There are a few other instances where the graph can break through the horizontal asymptote. The graph can never, ever, ever break through the vertical asymptote. That is like a brick wall, okay? You're not going through that. That's impossible. But it certainly is possible for the graph to break through a horizontal asymptote. There are really two ways to tell if that's going to happen. One would be to just do a t-chart and plot, find a bunch of values, just a bunch of values to be able to figure out if it crosses. Another way, which I'm not going to force you to which way, you can do whichever way you want. The other way is, and I'm just going to put a note here. Let's just put a note. And the note is you can determine if a rational breaks through a horizontal asymptote by setting the equation equal to the y value of the asymptote. So this technique is an excellent technique to determine if you have one of these functions behaving badly, where they break through the horizontal asymptote. They're not supposed to do that. Okay, that's bad, but they do. From time to time, they do. So that's, and we have an example where I can walk you through how to do that, how to figure out if the graph breaks through the horizontal asymptote. Okay, so I'm going to pause here for just a moment. These are the concepts that we're going to be working with today. Are there any questions about the concepts themselves? Are we okay? Okay. All right, so let's navigate to our page of examples. We've got 2 examples to work through today. So let's take a look at those. And we have several things to do. They want us to identify all the horizontal or slant asymptotes in part A, identify the vertical asymptotes in parts B. We need to find the intercepts. We need to find holes or points of discontinuity, graph, and domain and range. So we've got several things to do with each of these problems. And before we start, before we start any of those parts, we're going to factor and see if there is a way to reduce. And recall, when we cross out a factor from the numerator to denominator, it creates a hole. Okay, so let's see if that's the case in this one. So my numerator, let's see, so x and x, that's back sign is negative, so our signs have to be different. Let's see, that would be a 1 and a 5. Okay, and the denominator is, it's perfect. You can't factor that. So we see there's really nothing to cancel out. We don't have common factors in both the numerator and denominator, so this is not going to have a hole. So part D asked us to find any points of discontinuities or holes, so we're just going to write in part D, we're going to write none. There aren't any holes in this one. Now I do want to talk about, we did talk about briefly what would happen last time if there was a hole. If there's a hole and you would find the coordinates, you would just put like this empty circle at the hole. I'm just showing you, neither one of these has holes. So I just want to show you what if you got one. There is one, or one or two, I can't remember, on your homework. So you would just find the location on the graph and put a hole there, like an empty circle. That's how you graph a hole. All right, so now let's work on horizontal or slant asymptotes. Okay, so let's look at the exponents. This is a 2, and this is a 1. So the numerator is 1 more than the denominator. Do we remember what kind of asymptote that is? Is that a horizontal or a slant? It's a slant, so that means we're going to have to do long division to find the equation. That's what we do. So let's go down here, work on some scratch work down here. Let's do our long division. So the denominator goes outside our little division box. The numerator is what's inside. Okay, so let's work on our long division. We practiced that yesterday or last time also. X goes into x squared x times x is x squared. X times negative 3 is negative 3x. I always put parentheses and put the subtraction sign there because goodness gracious, I do not want to miss a sign. It's a common error for everybody. X squared minus x squared is 0. Negative 4 minus a minus 3. Negative 4 minus a minus 3 gives me a negative x, and then I pull down the next term. Okay, so let's go again. X goes into negative x, negative 1 times. Negative 1 times x is negative x. Negative 1 times negative 3 is a positive 3. Okay, subtracting. Okay, negative x minus minus x, that's 0. That's gone. Negative 5 minus 3 is a negative 8. So negative 8 is our remainder. Let's just this is the remainder. And when we're finding slant asymptotes, we really don't care about the remainder. I know it hurts their feelings. I hate to say that we don't care about it, but we don't. It doesn't impact us whatsoever. The slant asymptote is going to be y equals this right here on the top. Y equals whatever you have up there that I just highlighted in blue. That's what the slant asymptote is. And so let's write that out. So y equals x minus 1. So that's the equation of our slant asymptote. Okay, how are we doing? All right, part B is asking us for vertical asymptotes. That's when we set the denominator equal to 0, and we can kind of do that in our head because they're going to be, you will have factored it already. So we can kind of do that in our head. So our vertical asymptote is x equals 3. You can show the work if you want to, but you can kind of do it in your head. Part C is asking us for the intercept. So let's do a little scratch work down here. So y-intercept. Our y-intercept is when we're at the y-axis, right? That's where all the x's are 0. So we plug in I come up here and I put a 0 here and a 0 here and a 0 there. I mean, that's what I do. I would rather go, since the original one was not simplified, but I'm not crossing anything out, I can certainly go back to the original one and do some work if I want. So I'm going to put a 0 in for x, and I get negative 5 over negative 3, so which, equals 5/3. So my y-intercept is 0 5/3. Okay, my x-intercept, and we've done x and y-intercepts before, as this should be just a reminder. My x-intercept is when I set y equal to 0, and so really, truly, the numerator equal to 0, and it's, already factored, which is kind of nice. So we don't care what the denominator is as long as it's not 0, because 0 over 2 is 0, and 0 over negative 5 is 0. It doesn't really matter. So please don't be worried about us forgetting the denominator. All right, so my x-intercept, so I'm looking and see I have an x-intercept at negative 1. So we've got negative 1, 0. I have an x-intercept at 5. And so we had 5, 0. All right, so we've done those first 3 parts, actually 4 parts, and now we have to graph. So I'm going to put some marks up here. I think 5 all different ways is going to be enough. So just kind of, if you would just put 5 little marks here with me so we can graph. Okay. So I'm going to graph the asymptotes in a different color just so I can distinguish them apart. So I'm going to graph the vertical asymptote first. It's certainly the easiest one at x equals 3. So it would look like this. The slant asymptote is going to be a little bit more challenging, but basically what we're going to do is we're going to graph this line, the equation of this line with dotted lines. That's what we're going to graph it with dotted lines. I mean, that's it. So we know the y-intercept is -1, so I'm going to put like a little light blue dot here. We know that the slope is 1, so it would go like this. You know, it would kind of look like that. So I would recommend that when you graph it, you extend it out as far as you can so it like gets at least as far as the end of any one of those x or y axis. Okay, we've got those graphed. Very nice. Now let's just plot the points that we have. We know we've got 0, 5/3. 0, let's see, 5/3 is like what, 1 2/3, so it'd be like right here. And we know we've got, what do we have? We have -1, 0, which would be like right here. We've got 5, 0, 1, 2, 3, 4, 5, which is right here. Now, the points, our intercepts, may or may not be enough points to graph this. So how can we tell? Well, let's talk about it. I've got 2 pieces to graph because I have 2 asymptotes. 2 pieces, 2 asymptotes. If I had 3 asymptotes, I would have 3 pieces. That's just the way that it works. So I've got like sections that I can graph in. Notice that I am not trying to determine whether I cross a slant asymptote. That is not necessary. You do not have to worry about that. So I know my graph is not going to cross. I've got a piece of it over here. This is where I've got points. So I know I would connect these and I would extend the graph like approaching each of the asymptotes that's in its section. See how I have, and I'm just going to highlight, then I'm going to unhighlight. See how I have like 4 little sections? This is like section 1, that's like section 2, that's like section 3 and section 4. And it doesn't matter how you number them. I'm just showing you there's only 4 places to put the piece of a curve. And so we have actually, and I'm going to move that. So we've got one placed. We need to place the other one. We can tell that the other one is right over here because that's where the point is. The curve has to go through the point. So we've actually lucked out and we didn't really need any other points. We didn't really need any because this gave us enough information to know which sections to graph in. And then we just make our curve get close. It kind of molds or gets close to the asymptote. You want to make it get close. And so if we needed more points, we would just do a T-chart and we would just pick, points and we would sub them in and figure it out. We don't need any in this case. In this case, we don't need any extra ones. All right, so then the last thing they want us to do is find domain and range. So I'll put it in interval notation. Our domain goes from -infinity to 3, and then it picks up on the other side of 3 and goes to infinity. Then our range is -infinity to infinity. Everything is included in the range. All right, and that's our very first rational graph this year. How are we doing? Is everybody okay? Okay. So let's look at our second one. Let's get into our second one. We need to, of course, we're going to have to factor first. So let's do that. So f of x equals, let's see. So I've got They're both factored like FOIL. What do we have? X, and the top one is negative, so plus minus. So what, plus 2 minus 1 looks like? In the denominator, we've got the x and the x. Again, a minus, so plus minus. Let's see, what do we have? A 1 and then a 3. Okay, so it doesn't look like we have anything that cancels. So this does not have a hole either. That's why I wanted to really explain. So, for example, in this other one, maybe if we had a hole, like this would be where, this is an example where the hole would be. You'd put like a hollow circle right there. That's where the hole is. And you wouldn't let the graph go through it. But, I mean, we don't have one, but that's how you would graph it. So, no holes. So, we're going to put none for point discontinuities. There aren't any. Okay, so let's look at part A, wants horizontal or slant. So let's investigate. Okay, so I've got a degree 2 and a degree 2. Okay, those are the same. Remember, when they're the same, we divide the coefficients, and that's our lovely implied 1. So my horizontal asymptote would be y equals 1. Okay, wonderful. Vertical asymptotes, that's when the denominator is 0, and those we can just kind of do in our head. X equals negative 1 and x equals 3. Okay, wonderful. Now we need to work on intercepts. So let me go down here and let's just do some scratch work. So the intercepts, the y-intercept, let's see, that's where you make all the x's 0. So that would be negative 2 over negative 3, or 2/3. So my y-intercept is 0, 2/3. Okay. My x-intercept, if you recall, the x-intercept is where we set y equal to 0. So 0 equals x plus 2 times x minus 1. It's already factored, which is kind of nice. So we can just read the intercepts out of that. So that would be what? Negative 2, 0, and 1, 0. Okay, so I want to pause there for just a moment. We have all of our asymptotes, and we've got all of our intercepts. Okay, any questions so far? All right, so what we want to do, or what I'm going to do, is I'm going to set up my graph, and I think 5 dashes either way is sufficient. So I'm going to do that first. Let's just put 5 little marks. Okay, so let's graph our asymptotes. We've got y equals 1, so that's going to be like right there. We've got x equals negative 1. There's x equals negative 1, and we have x equals 3. Okay, very nice. We don't have any holes. Let's go ahead and plot the points. Might as well. So 0, 2/3. So we're looking like around here. 0, 2/3. We have negative 2, 0. So like right here. And we have 1, 0. Okay, that's what we have so far. Now, we have a horizontal asymptote, so we really need to check to see if this graph busts through the asymptote. Is it going to do it? Let's practice that. So what do? Our y value of our asymptote is 1, our horizontal asymptote. We're going to set 1 equal to the equation, which is x squared plus x minus 2 over x squared minus 2x minus 3. Now, what I would recommend that you do is I would recommend that you turn this number, whatever number this is, into a fraction by putting it over 1. That's my recommendation, and that you cross multiply. That will make your life easier, much easier to be able to find your, if it crosses or not, if we're going to cross the x-axis, or the horizontal asymptote. So let's cross multiply. So 1 times x squared minus 2x minus 3 is, x squared minus 2x minus 3. 1 times x squared plus x minus 2 is just that. So that's kind of handy. Our horizontal asymptotes aren't always going to be 1. That's just kind of handy that it is. It could be 0, and then you'd say 0 over 1, or it could be 2, and then you would say 2 over 1. I mean, whatever it is. All right, so nicely, the x squareds cancel out. That's kind of a little helper. So I'm going to move the x's to the right. So that would give me 3x on the right, and then I'm going to move all the numbers to the left. -3 plus 2 is like a -1. So this one does behave badly. This one is going to cross the asymptote, the horizontal asymptote, at -1/3. So I'm going to go ahead and put that up here. We're going to put that at -1/3. I'm going to pause here for a second. Does everybody have the cross multiplying and solving? Yes.
What would it equal if it didn't cross the asymptote?
Oh, good question. So if it doesn't cross the asymptote, what's going to happen is you're going to get imaginary solution. It's going to be imaginary. Like you're going to have an x squared left. You see how our x squareds went away? If the x squareds go away, it's going to cross.
Okay.
But if the x squareds are left, then you're going to have a quadratic, and it probably isn't going to factor, so you have to check it with quadratic formula. And if the solution is imaginary, then it doesn't cross.
Okay.
Does that help?
Yes.
Because there will be plenty that don't cross, and that's what will happen. Okay. Other questions on the whether it crosses or not? Okay, so we're going to go to x equals -1/3, and we're going to put a point on the asymptote, like right here. Okay, so we know that it only crosses there, and we're going to point out there's 1, 2, 3, 4, 5, there's 6 different sections, right? We got 6 different sections, and how many pieces are we supposed to have? The number of pieces matches the number of asymptotes. How many pieces are we supposed to have? 3. So only 3 of those sections should have something in them, except, it behaves badly. So this middle section, let's graph what we know. This is going to cross through, so it's going to go like this. And when it crosses through, it actually accesses 2 sections instead of 1. That's why it's behaving badly, right? That's like, no, you're not supposed to do that. Well, it did it anyway. Okay, it got hold of 2 sections. They're only supposed to be each in 1 section. Now, I know it's not going to cross anymore, so I know right over here, see this point that we have right over here? That's going to have one of those little L's in it, the little curve things. So we're going to draw it, so here, and then it's going to approach, but it's not going to cross. It's going to approach but not cross. Now, we will never have one of these little L's. We're never going to have another L on top of it. That's not a thing. So there's never going to be anything right there. We never have to worry. That section, that section is out. There's not going to be anything there. It's impossible. So we have only graphed 2 pieces. We need 1 more. So where is the other piece going to be? I mean, we don't actually know, but we know it's going to be either here or here, right? Those are our only choices. Okay, so how are we going to figure it out? This is where we need a t-chart. And we need to pick an x value over here that's in these two sections, and we need to, find the y value. So you know me, I kind of try to avoid big numbers, and okay, truly I try to avoid fractions. I do. So I'm going to pick an x value of 4. You can pick any x value over there if you want. You can pick 3.5 or 5 or 10. It doesn't matter. All I'm trying to figure out is whether this little piece is going to be in the top or the bottom. That's all I'm trying to figure out. Okay, I know it's not over here because you're not allowed to stack them, top to bottom. That's not a thing. Not there. So it's got to be here or here. So I'm going to plug in the 4. And again, my little big number. So I'm going to put the 4 within here in the factored one. And I'm going to say 4 plus 2 is 6. 4 minus 1 is 3. 4 plus 1 is 5. 4 minus 3 is 1. And so that's what 18/5. That's how I would calculate the y value. You can really do anything you want. You can put it back in the original because it didn't reduce. Anything you want. But we can see that our point is at 4/18. Let's see, what is 18/5? What's like 3 and something, right? 3 point something. So that means, let me get rid of my little marks here. That means that at 4, we're at 3 point something. 1, 2, so up here somewhere. So now I know exactly where to draw the third piece. The third piece is going to be in that top right little section. So I'm going to draw my line through here. And there's no crossing vertical asymptotes ever. And there's no more crossing the horizontal. There's only crossed one time. That's what we did when we found that. Only one time, and we've already done that. Okay, how are we doing so far? Only one thing left to do, and that is to find our domain and range. So let's do that. Domain is -infinity to -1, -1 to 3, and then 3 to infinity. Our range, our range is everything again, just like the other one. That's kind of nice. It doesn't always end up that way, but that was nice. So it's everything. All right.